Tolerance stackup analysis fundamentals. Why tolerance stackup analysis? To ensure that all the parts fit together in assembly. To measure the allowable value in form due to the variations in manufacturing. To understand the worst case fit and form of the parts in an assembly. To manufacture the parts by assuring the allowable variation in size and location. What is stackup analysis? Stackup analysis is a mathematical calculation used to measure the gap and interference value between the parts in an assembly due to the variation in its form, orientation, and location. Stackup analysis is an analytical reasoning tool used to decide the allowable values of interference or gap between parts from the key perspectives of its functional requirements in an assembly and its manufacturability. Advantages of a tolerance stackup analysis. Thorough understanding of the functional requirements of each and every part in an assembly. Prevention of quality defects and improved product quality at its design stage. Cost reduction due to the optimized tolerance. Reduction in development time to market. Improved customer satisfaction. When should we do stackup analysis? At design stage before drawing release. Types of stackup analysis: a linear stackup, a radial stackup, part and assembly stackups. 4 basic steps of stackup analysis. First, clear definition of the problem. Define where do you want gap or interference in an assembly. Second, select acceptance criteria. What is the desired answer or result in the gap or interference variations? Third, identify the stack path in an assembly. What are all the features of sizes or features that impact the variation? Fourth, perform mathematical calculations. Assumptions in stackup. Variations in microns due to the following factors are not considered in stackup analysis. Parts are at room temperature, parts are to print drawing, no wear, zero deflection, no unusual conditions. Problem definition. The clear definition of the problem involves 3 sub-steps. A. Document the stock objective. B. List the conditions under which the stock is being calculated. C. Label the start point, end point, and direction of the stock. Document the stock objective. The stock objective here from the drawing shown. For the drawing shown, find the maximum and minimum distance between the shoulder and the left side of the group. List the conditions under which the stock is being calculated. The temperature of the parts, whether the parts meet print specifications, whether the stock includes or excludes wear, the amount of deflection on the parts, any unusual conditions present in stock. Label the start point, end point, and direction of the stock. What is a start point? Start point is a feature in the first part we named in the problem definition. The end point is another feature in the second part, a feature in the second part. The end point should always be a feature in the second part. Stock indicator as shown in the drawing. Directions: the positive sign for the arrow pointing towards the end point and negative sign for the arrow pointing away from the end point. Purposes of stock indicators. There are 2 purposes. Why do we use stock indicator? To add or subtract a dimension in the stock calculation. Whether we have to add or subtract a dimension. For that we are using the indicators. The positive sign for adding a dimension, negative sign for subtracting. And second purpose, to interpret the stock answer. If there is a positive sign in the answer, implies there is a gap between the parts. If there is a negative sign, implies an interference. Rules for starting point. Axial stacks start on the left, radial stacks start on the bottom. Stock indicator example. Start point. A feature is a surface of start point in this stock indicator example. It is a feature and surface of the shoulder. That is first part in stock. The second point, a feature a feature that is the surface of that is a surface of a groove. That is second part in stock. Stock objective here is find the maximum and minimum distance between the shoulder and the left side of the groove. Stock indicator the positive and negative directions for the stock. Acceptance criteria. Select the acceptance criteria. Writing down the answers or design goals that you desire before you do the mathematical calculations of stock for lowering product cost. Select the acceptance criteria. That is the critical step here in this Stackup analysis. Writing down before you are doing the Stackup analysis. That is writing down the answers or design goals that you desire before you do the mathematical calculations of stock for lowering product cost. Identification of the third step, identification of stock path. What is a stock path? A series or chain of distances, that is path dimensions from start point to end point of a stock. This chain consists only of known dimensions. There is known dimensions on the drawing or a derived dimensional value, that is calculated dimensional value from the drawing. To identify the stock path, locate the shortest continuous chain of distances or path dimensions or derived dimensions. Mark each dimension with a line, place a dot at starting point and an arrow at its end point. Label each distance with a letter, example A, B, C, etc. Start path example. The stock labels here shown A, B, C. A stock indicator with a sign positive and negative, and stock objective is marked here. Here we have to find out the maximum minimum distance. And the stock objective in mathematical script, one is equal to, that is minus B plus minus A plus B mathematical minus calculations. Now procedure. Enter the value of distances from the stock path and to the stock form. Set achievable variations in each distance. Enter acceptable maximum and minimum distances in two different columns. Add each column of numbers. Check the subtotals. Evaluate the answer analytically. Assembly stacks. Same as step 1 to 4. Based on worst case meeting of parts, assemble the two stacks to be done to find the minimum and maximum of the analyzed dimension. And points to remember in assembly stacks, each part in the assembly should touch at least one part. Stock path can pass on from one part to the other through the contact points. It's an example of a stock analysis. Here X is the mark, is a gap. We have to find out what is the minimum and maximum gap or distance. So A, B, C, D are labels of the distances in the stock path, and the stock calculation is done mathematically. The gap X is equal to minus A minus B plus C minus D. The answer is plus 1 with a tolerance variation of plus or minus 1.7. It is a very simple example. We'll see in detail with the GD&T samples in part 2.